Well, hi there, thanks for tuning to my YouTube channel. The CNC Dude here with yet another exciting project, or I should say the conclusion of a project. My last video, I was talking about how to make a CNC Vise splash guard by using a laser engraver. You know, I kind of chickened out of that video because I didn't have the screws necessary to attach the splash guard into the vise. The screws are 7/16, 14 threads per inch. So I kind of whistled out because I looked at my stock and I couldn't find them, and I thought, you know what, I'm gonna have to buy them. But here I am on a video talking about how to use your tools to make tools, and I didn't make the screws. To be honest, I'm really not into making screws. To me, screws and bolts is something you buy. There is nothing glamorous about making a screw. It's not like I'm gonna wake up and as I'm heading out to work, I open up the door only to find a bunch of reporters. There he is, the guy that made a screw! How quick, tell us, were you in any kind of danger? And a bunch of paparazzi come out of the bushes, taking pictures. So I'm thinking, I'm gonna go into McMaster, I'm gonna find a screw and buy a bunch. Well, they're about 60-something cents a pop, and I would need to buy 10. So that's close to $7 for some shipping and handling, plus like 3 or 4 days of waiting time. But I also know that if I get these 10 screws, I'm gonna use 2, and the other 8 are gonna go into a bin, where I am positive they're gonna be looking at me and laughing. Where are the screws you're never gonna use? So I said, screw it, I am making the screw. Screw it, I'm making the screw, man, that's awesome. Alright, so I went to the metal supermarket where I acquired this hex bar, 5/8 cold roll steel hex bar, which I'm gonna put on the lathe and we're gonna make the screw. Let's get to it! I'm here at the lathe where we're going to cut this small piece of hex bar into 2 screws, 7/16, 14 threads per inch. I'm going to try to use 2 methods, and we'll see those soon. But first, let me tell you that I wanted to cut this on the saw instead of using the 3 feet hex bar because, you know, I really don't like having stuff coming out of the lathe. It could get dangerous, so no need to increase the risk if unnecessary. I'm going to work with this guy. First step is to face it. Now, before I get started, let me tell you that you know, this is something we could have done on the mill. We could have basically used what is called a thread mill and programmed the helical of the screw and gotten the screws done on the mill. With a CNC mill, it would have been a CNC project. However, that is not a trivial endeavor. First of all, I've never done it, and I fear that I may break a few thread mills in the process. If these thread mills were like $5 or $10, it wouldn't matter to me. But you know, the cheapest thread mill is $50 that I was able to find, and the one for this screw would be $90. A thread mill could be as much as $700. So I don't think that's for the faint of heart. I think I would prefer to have much more experience before I go into something like thread milling. Now on the lathe is the perfect tool for doing threads. So it's definitely going to be the cheapest solution. So no need to try to do on CNC something that is going to get preposterously expensive when you can easily do it very cheaply on lathe. That is looking good. What I need to do now is reduce the diameter of the hex bar, or actually create the diameter, what is called I guess the large diameter instead of the small diameter, or the outer diameter instead of the inner diameter. And on this screw, the outer diameter is 7/16, which is 0.4375. Now I have a DRO, so I'm going to be using that. But at first, what I'm going to do is make it round. Right now it's a hex bar, so what I'm getting is obviously 6 sides, and we gotta get rid of that. That is gonna get a little bit chattery. It's basically a discontinuous cut. Preferably, you would like to be cutting on a continuous cut. That way there is no, you know, what we like to call on motion control torque ripple, right? There's going to be a ripple because the blade is going to be coming in contact. No contact, contact, no contact at a very fast speed. So not a pretty sight. Hopefully the carbide tip doesn't take it too hard, but it's very possible the carbide tip is not going to like it. We'll see. Okay, I have been able to remove the hex bar. I'm going to take now my micrometer and I'm going to measure that diameter. And that's going to be my starting diameter. Basically what I want to do is start subtracting with my DRO. So as soon as I reach, I'm gonna measure how much it is, and I'm gonna put it on my DRO, and that's gonna tell me how much I'm basically moving in until I reach 0.4375. 0.560. Okay, now I have my DRO set where when the tool is touching the edge that I just cut, it says 0.560. So as I move the cross light on direction towards the screw, I'm gonna see the magnitude of my DRO decreasing. When my DRO says 0.4375, that is the moment in which I have reached the diameter that I want. I am now going to remove the material so that I can take my diameter from 0.560 to 0.4375 inches, and I'll do multiple passes to get there. You know, 2 or 3 roughing and then like 1 finishing. Let's see how close I am to 0.4375. .435, so I am 2 mils too long, two away. But you know, that's not a big deal. That should work perfectly fine. I'm actually amazed of how good this works. I am ready to thread this guy, but you know, I am going to cheat a little bit. As it turns out, I have a die to cut 7/16 14 thread per inch screws. You know, when I was a teenager, I used to be always saying, in love and war, everything is allowed. I think we should add that in love and war and machining, everything is allowed, as long as you don't lose a finger or any piece of bodily meat and bones. Now, here is something important. All joking set aside, I am going to ensure for my safety here, because I am not looking for a trip to the ER. So my lathe is energized as it is, and I'm going to use this with the piece of material on the lathe. Anything could happen here, and you know, if this thing tramples, just gets in and tramples my hands against the bedways or anything, could result in an extremely painful endeavor. So what I'm going to do is I'm going to flip the fuse. I am fairly confident that is good enough to protect me for 3 reasons. First of all, the fuse has completely de-energized the lathe. That means that right now the lathe really cannot be enabled. But let's say the fuse is, by pure bad luck, the fuse becomes connected and now the lathe is energized. Well, I would see a light in here. But let's say that by pure bad luck, the light also gets damaged and now I don't see it. There's also a power cell. Right now, the lathe will be on reset. So the power cell would need to be flipped for the lathe to be engaged. let's say that I'm in so bad luck that the reset relay in there is also damaged, and now it could start. Well, I have a switch in here, and unless I flip it on one way or the other, the lathe really cannot start. I would need 4 switches to be effective for this guy to represent a problem for me. You know, I'm an electric engineer. The odds of something like that are so small that I'm not even going to worry about it. It would need to be something like on one of those movies, on Final Destination, when the angel of death is trying by all means to try to kill people. It will have to be something like that, something so preposterous and ridiculous that I think I'm in good hands. Now let me add one thing before we move on. I believe that the lathe is the safest tool in the shop. Way safest than the milling machine, a sander, a grinder, or a saw, or even a drill. However, at the same time, the lathe is the deadliest of the tools in the shop. I cannot imagine any of the tools that I mentioned before killing a human being. It would be tough for you to get killed by a milling machine, unless it's like a humongous milling machine. But you know, a bench mill, or even my Tormac PC 1100, even if I put a half an inch mill, for that thing to kill me would require a lot of bad luck. The lathe, however, it doesn't need that much bad luck. All you need is the bad luck enough to be caught by the chuck, and that could result in a lot of pain, an extremely hazardous situation. I've seen pictures of people transformed into corned beef. So always, never underestimate this tool. It is the safest. It's very hard to get a cut with. It's very hard to get a cut. But if it grabs you, that could be the end of a big piece of you and me. All right, I am going to use my die. Right now, what I want to do is put my gearing in slow, so that is the hardest for it to move. It's very hard to move this chuck. And I'm also going to use my my tailstock, so this guy is as square as possible to the part. This is the simplest way of making this screw. And in essence, I don't need the lathe to do this, but I'm just going to take advantage of the fact that the screw is, this thing is pretty stable. The last step before getting started is to apply a little bit of, basically cutting oil. At some point in time, you have to remove the tailstock. We're almost there. I'm going to flip the die now so that I can cut to the shoulder and get it as good as possible. I think that's it. Man, it's looking nice. All I have to do now is cut the screw from the hex bar, and for that I'm going to use, obviously, a cutoff blade, quarter. Screw number 1. Looking nice. All I have to do now is remove this guy, but it should be a piece of cake. I did a little bit of a chamfer in this side and this side, and also in here. Man, this looks like a screw that you would have bought on McMaster, except that it was made on the shop. Alright, I am ready to make my second screw. The way I'm going to do this, actually, I'm going to use the lathe as a lathe. I'm not going to just use it as a vise as I did with my first part. Actually, I'm going to use the gear, I don't know what you call this, the gearing and the screw and the dial to make a 14-inch thread on a piece that I already turned to 0.4375 diameter. I have placed my fish gauge, so that tells me that my 60-degree angle tool is square to the piece, which is kind of important. But I'm going to cheat here a little bit. The tool I'm going to use is basically a conventional carbide insert. Really, I don't think this is meant for threading. So this is most likely not going to be the most perfect screw on the face of the planet. I think it will work, and you know, we're just attaching a piece of acrylic, so it's not like, oh my god, the bridge will collapse if we don't do this right. If you're designing a bridge and building part for a bridge, make sure that you do it right. Now, you know, there are people like Mr. P222, also known as Tubal Cain, and Tom's Techniques, and I bet there are dozens others that can tell you how to grind a tool. I'm just going to use my insert, and I'm going to hope that this works, but we'll see. According to my lathe manual, which actually I had to use the Grizzly manual because the Enco manual isn't good enough, according to the Grizzly manual, I have to set my position here on my lever on B, and then my threads per inch, position 8 will give me 14 threads per inch, so that has been set. I have also turned the diameter to 0.4375. My tool is squared, so now all I have to do is select my screw. Okay, I have selected my screw, and when as the lathe is going, I'm gonna have to engage my half nut whenever I have a number on the dial. Okay, any number basically. So engage my half nut whenever there is a number on the dial. And I also have to ensure that I am feeding my tool so that I get the inner diameter is 0.3499, so 0.35 basically. Now there are, in theory, I am supposed to move my my cross slide or my compound slide to 20 degrees and then use the compound slide to do this. I'm gonna see if I can make this work without doing that. But you know, I think I think I'm tripping here. Well, let's take a look. Let's see what happens. All right, I don't think I'm ready to be a thread expert on the lathe. The screw is here, but it doesn't go in. It's very possible that the tool was done wrong. I mean, this is a forming operation, so how you form this thread is crucial. Also, it is possible that I didn't go deep enough, or man, I don't know, what could it be? But I'm gonna cheat again. I have my trusty die, so all I have to do is most likely fix this thread, and this can be very easily done. And get it to go. There we go. And now I'm going to use my wrench, and I'm just basically going to rethread this guy. You know, if it gets the job done, that's all that matters. It's not a lot of material coming out, so I'm thinking that perhaps the depth was not right. You know, I look at this and I have no idea why it didn't work before. But it's not like I have a bionic eye and I could say, ooh, look at that, yeah, I have like a big clump of atoms out of where they were supposed to be, and this put them where they were supposed to be. They both look like perfectly fine threads to me, but obviously the first one didn't work, and now it's just a matter of figuring out whether this is going to work. let's give it a try. I mean, it should work. The die is meant to do what it's meant to do. BAM! Screws! Screw you, screws, I made you. Well, here they are, the two screws to attach my splash guard into the vise. You know, making screws was a lot of fun, and it's actually exciting that I didn't have to buy them or wait for them. But these screws are useless if they don't work, so let's make sure they work. Here's my splash guard, here's the vise, and here we go with screw number 1. Man, it's going like butter. Amazing, gorgeousness indeed. I'm screwing the screw. Let's put the other one. Working like a charm. I'll be darned. Simply amazing. Yet another example of how we can make tools with our tools for our tools. 2 screws, splash guard, project complete. Now, you know, anybody can say, well, you could have gone into the Torma website, buy the splash guard for like $20-something, and then go to McMaster and buy the screws for like $6 or $7, and wait like half a week or a week, and you would have gotten it there. So let's say, I don't know, $40 including shipping and handling, right? And so if we quantify how much is our hours worth, or even if you want to quantify how much is the hour of a machine shop worth, if it is, let's say, $50 or $100 an hour, and it took 2 or 3 hours, this almost sounds like an no-brainer that we're wasting money and efforts. It would have been better just to buy it, but the satisfaction of making these by ourselves, I mean, you cannot put a price on that, right? Also, I know that when this guy breaks, I'll just make another one, so no biggie there. And if I ever need a screw, which I don't have, I just make it. So the knowledge, the experience, the satisfaction, I don't think we can or should put a price on that. Well, project complete. I think this has been an exciting project, and I thank you for tuning to my YouTube channel to take a look at it. There will be much more to come, so keep tuned, and I'll see you on the next time, alright? Take care.